Okay, 12.6 is properties of tangents. And one thing that we've gone over in our last chapter is if you have a tangent to the circle and a segment is connected to it, and the segment is a radius, that is going to be forming a right angle with the tangent line. So when we do this, we're going to be using a lot of right triangles, which will help us with Pythagorean theorem. So if we look at our first example in the diagram, RS is a radius of circle R, and they want us to figure out, is ST tangent to circle R? So if it was tangent, this angle in the bottom corner would be a right angle. So we want to make sure that this works for Pythagorean theorem. If it doesn't, then it's not going to be tangent. So remember, Pythagorean theorem is your a squared plus b squared equals c squared, where c is always opposite of that 90-degree angle. So we're going to have 24 squared plus 10 squared, and we want to figure out if it's equal to 26 squared. So if we type this in, 24 squared plus 10 squared, that is going to be equal to 676. And if we look, 26 squared is also 676. So because these two are equal, we can say that ST is tangent to circle R. And that would be our answer. So if it works in Pythagorean theorem, then we know that segment is tangent. So again, let's try in the next one. So the tangent line is the one on the outside that meets the circle at one point, and that is also where the right angle is. So AB in this one would be 12 and 16, and our C value is 7. So if we look at this, hopefully you can see just by looking at it that it's not going to be a right triangle. So those two are not going to be equal. So because they're not equal, ST is not tangent. And that would be our answer. Okay. Looking at example 2, we have done problems like this before, where in the diagram they tell us B is a point of tangency, which means that this line is tangent and that we have a right angle. And they want us to find the radius R. So we have our A and our B values, our 77 and R. And that's going to be equal to our hypotenuse squared. Now remember, for this one, our hypotenuse is two parts that we're adding together. So when we square that, that means we're taking this and you're multiplying it by itself again. So you are going to have to FOIL for this one. So when we take 77 squared, we're going to get 5,929. And 49 squared is going to be 2,401 plus 49R 2 times, and then plus an R squared. So when this happens where you have a square term on both sides, sometimes it will end up disappearing. And when that happens, that means you don't have to use the quadratic formula or FOIL. So we have 5,929 equals 2,401. We're going to add those two together to get 98R. And our goal is to figure out what R equals. So we have to take 5,929 minus 2,401. And then our last step would be to divide both sides by 98. And that gives us our answer of 36 for our radius. Okay. Our last part is talking about congruent tangents, and two tangents are going to be congruent to each other if they have a common external point and they're tangent to the same circle. So because these two segments, RS and TS, both start at point S and are tangent to circle P, then they are congruent to each other. Then looking at our last example, QR is tangent to circle C at point R, and QS is also tangent. So because these two start at point Q, that means the tangents are going to be congruent. And they want us to find the value of x. So because we know they're congruent, we're going to take the two lengths of the tangents and set them equal. Once you're here, you're going to go ahead and solve to figure out what x is. And that is going to give us our answer of 9. And you want to make sure you read the problem. This one, they wanted us to find the value of x, but sometimes you will have to plug it back in to find the length of one of the tangents.